How hairy do you think you are? Well, you may be surprised to know that as well as the hairs on the surface of our skin, the insides of our bodies are covered in microscopic hair-like structures. But why do we need such hairy insides? Well, researchers at the Massachusetts Institute of Technology believe that these hairs play an important role in how fluids are transported throughout our bodies. I caught up with researcher Jose Alvarado to find out more.
There are a lot of surfaces inside of our own bodies that are coated in hairs. And this ranges from our tongues to our intestines to a lot of body parts, including, and for me this is the one that blew my mind the most, even our blood vessels. Even the smallest ones, they're coated in these protein sugar chains, which jut out into the blood vessel. And a lot of these hairy surfaces inside of our own bodies, they're immersed in fluids. And so I just thought it was a very interesting physics problem to study how these hairs and fluids interact with each other.
Yeah, indeed. It's an interesting thought that we're all hairy inside. So, can you talk us through just the experiments that you did? How did you go about investigating how these hairs work?
Well, we have a lot of examples of hairy surfaces inside of our own bodies, but these hairs tend to be very small. And it tends to be very difficult in experiments to work with something so small. In order to model these small hairs inside of our bodies, I'm making larger hairs. And the way I do that is I essentially make rubber hairs by casting a mold. And then I can produce carpets of these hairs, which you can feel and touch with your own fingers. I did some very classical or very traditional fluid mechanics work. I took a cylinder, which I coated with a whole bunch of these hairs sticking out of the cylinder. And then I immersed this cylinder in a larger cylinder that's filled with fluid. And what I can do is I can rotate the smaller cylinder coated with hairs inside of this fluid and measure the forces or the stresses on the hair surface.
Interesting. So, can you break that down to what this all means in terms of, did this give you any idea of what role they have?
So there are a lot of examples of in nature of flexible objects that change their shape when, say, a fluid flows past them. When a fluid flows past a solid object, the solid object feels a force which is called the drag force. If the fluid changes the shape of the solid object, the drag force decreases. Drag reduction is a way for a solid object to minimize the drag force it feels from flowing fluid. What we find is we characterize also similar drag reduction for these hairy surfaces. We hypothesize that this drag reducing behavior that we measure in our experiments applies to all the different hairy surfaces inside of our own bodies. One example in our kidneys, they're known to have these very long hairs that when they bend, they send a signal back to the cell saying that there's a fluid flow, so they act as flow sensors. What we think is happening is that this drag-reducing property of these hairy surfaces protects the mechanisms inside of the hair that transmit this signal to the cell, protects them from damage or from overextension.
So, our hairy insides actually protect us from the full force of fluids racing through our bodies. And this could have an interesting application in building smaller hydraulic robots.
What I've been able to make with these hairs is a microfluidic diode. What does that mean? A diode in electronics is an object that prevents current in one direction but allows it in a different direction. And the microfluidic diode is a fluid-based version of a diode where fluid flow in one direction is allowed, but then fluid flow in the other direction is hampered. And we think that this could be very useful in the future for making small autonomous hydraulic robots.
Who would have thought that the hairs inside of our bodies hold the secret to designing hydraulic robots? That was Jose Alvarado, and his work is published this week in Nature Physics.